Okay, welcome to another Orbiter 2010 video. And in this video, I am here at Brighton Beach on the moon. And this time I'm going to take the XR5 out for a spin rather than using the XR2. No special reason other than the fact that I just don't really use the XR5 that much. So I thought I'd change things up a little bit. So in this mission, I'm going to do something that Dimitri actually just taught me last weekend. I'm recording this video Saturday, January 11th, 2014. And just last weekend, I was on Skype with Dimitri, and he showed me how you can go from the moon, fall back to the Earth, and then instead of getting into orbit around the Earth, you kind of use the Earth as like a gravitational sling to then throw you out towards one of the planets. And in this case, the planet of choice is going to be Mars. So it's a pretty cool way to accomplish that trans-Martian injection burn. You know, normally it would cost you about 3,600 delta V, somewhere in that neighborhood, from low Earth orbit. But doing this method, we can actually, by the time we get back to Earth, we're traveling so fast that we only need about another 450 to 500 DV, somewhere in that range, maybe even a little bit more than that. But that'll give us the kick that we need to get out to Mars. So it's pretty cool. Of course, you have to get to the moon in the first place, but, you know, bearing all that aside. So let's go ahead and set this up. This scenario is, again, using today's date. So the first thing I'm going to have to do is find a date that I can use to go to Mars. So let's do what we normally do. We'll load transx on both sides. And we'll go escape. This is actually also presents an interesting point that I haven't actually covered in any other video. And that's basically just how to go from a moon to another planet. It's a little complicated, and I'll kind of get into that here in a minute. So we need to escape the moon. Then we'll go forward into stage 2, and in stage 2 we want to escape Earth. Then we'll go forward to stage 3, and we want to go to Mars. And then if we go forward again, we can create the final stage. Now, the problem you have with this particular setup is that when you go to, what is it? Which stage am I looking for? Stage 2, I believe. This is our Earth stage. And we're saying that we want to go to Mars. Just bear with me for a moment. It's been so long since I've actually gone through this that I'm having a hard time remembering what the problem is. The problem basically is with transx, the default stages, the way they're set up, it doesn't give you the information that you need. So just let me, I think I recall now, it's in this stage 3, we're saying that this would be the stage where we want to go out to Mars. So if we said that we turn maneuver mode on, and then you can see as I'm adding in prograde, nothing's happening. So this is the problem that you run into when you try to go from a moon of a planet to another planet, or from a moon of a planet to another moon on another planet. You get into this issue where you can't set up your maneuver, or at least it seems like you can't. So there's actually some things that we have to do here in order to work it out. The main thing is that you can't think of this trip in step 1, step 2, step 3 like we normally would. You actually have to start your planning in the middle, and that can kind of maybe be confusing for some people. But what I mean, if we go back to it would be stage 2, and we're saying, okay, this is our this is the Earth, this is the moon, and we're saying if we want to drop down to the Earth, then we would say, you know, typically we need to put in some negative prograde velocity, like so. And then that gives us sort of our normal looking transx information that we would be used to if we were planning a trip back to Earth. But then you go forward into this side, and you don't have any data. And again, if you try to set up a maneuver here on stage 3, you know, if we turn maneuver mode off, then back on, and you try to set up the maneuver here for going out to Mars, it just doesn't do anything. So what we have to do, let me first of all shut stuff off. So turn maneuver mode off over here, and then go back into this stage and just reset everything. So what we need to do is we need to go to stage 3 and go to view setup, and we need to turn advanced on, and then we have to turn auto plan off, and that will allow us to set up the stages how we want. And what we need in this stage, instead of view maneuver, we need view escape plan. So let's go to plan type, which I can't ever remember which plan type I need, so I actually just go through them. So I'll leave it on cruise plan, and that's eject and sling. That's not what we want. So plan type, initial, escape. So that's what you need. Plan type should be initial, and then the plan that you want is escape. Now, when we press VW, we have an escape plan instead of maneuver. And what this lets us do, this lets us set up our trip from Earth to Mars. Now you're thinking, wait a minute, you're on the moon. Shouldn't you be setting up your trip from the moon to the Earth first? And again, no. Due to the way these, due to the way this type of planning works, you actually start your plan in the middle, and then kind of go back to step 1 later on. It's not that complicated. So view over to escape plan, and then go to okay, actually it's not escape. Making another mistake there. So we want eject, not escape. All right, let me go back to plan type. So we want cruise plan, and we want eject. All right, now we've got our eject plan. See, I still get confused on this stuff myself, and you just have to go through it. It's easy enough to figure out what's wrong when you're looking at the escape plan, and you see that you're missing prograde and you're missing all the other variables. So then just go back to view setup and change the plan type out. One of these days I'll have it memorized, but for now I don't. So now that we have eject plan, which is what we want, now we can start inputting the prograde. And actually what we can do, I'm just going to use the auto min. So I'll set prograde for auto min. I'll set outward for auto min. And the plane change we want to leave at 0, and there's a reason for this. I'll try to cover it a little bit. I don't completely understand it myself, but Dimitri was just telling me that for this particular type of flight, it's important that you don't use any plane change. He's going to show me later on how to set this up using plane change, but for this particular flight, we need the plane to just be 0. So make sure that you don't change that at all. Now that we've got prograde and outward on auto min, we can come to the date and just start fiddling with the date until we have, what we think looks good. And that's not this. That's total flight time of 155 days, but the delta V is a bit high, and you can see that we're swinging way out into space. It's not very ideal. So let's just kind of keep bumping the date forward. We go to a rough setting. And I'm kind of looking at the time of flight at the moment. I want that to be, obviously much lower than a year and a half. Okay, we're getting now down to a point where we're going to have another solution soon. So let's go to course. Actually, I'll leave it on rough for now. This actually doesn't look too bad to me. We have a total flight time of 183 days. That's only about 6 months, and a total delta V of 2.9K. In this flight, I'm not going to worry about being, a DV freak, so to speak. This one is more about demonstrating this method of going from the moon to the Earth, sling out to Mars, and so I want to focus more on that rather than sitting here and trying to get the DV worked out so that it's, every drop counts kind of thing. All right, let me go forward here and just check the encounter. It shows obviously we're still off, and we can see here the closest approach isn't quite where it needs to be, so we'll continue bumping the date forward and let AutoMin work its magic. Although as I do that, it's adding in a lot of DV, so I probably won't take this date after all. Yeah, I'm going to go ahead and go forward again because that's just, you know, I don't want to have a total disregard for delta V either. Okay, so we'll see what we have over here. And that's still not quite coming together. Looks like we'll have it here because we'll have basically, yeah, we'll have it here. We have a natural time where we're going to arrive in plane because the line of nodes is where it needs to be. So we'll just go with this one. It's going to be the best. Just doing a little bit of fine go all the way down to hyper. Basically, we're there. You can see, you know, there's Mars. Just do a little bit of, just trying to get that closest approach down to a minimum point. So 230 days, not too bad. And the delta V 2.9, that's a decent flight. Okay, so there we are. We're at Mars, or crashing basically straight into the middle of it. So before we do anything else, the main thing that we want to do now is change the date in the scenario. It doesn't do us any good to sit here and refine things when we have a date that's so far out into the future. So Control F4, scenario editor, date. And we need to put in 5826. Let's put in 58238. And the reason that we want to do that, that's basically 30 days prior to the eject date. And I'll get into explaining more on that here in a moment. You can put in the last 4 decimal points if you want, but you don't have to. So apply, done. And now you can see when you do that, it kind of messes things up a little bit, but that's okay. Just basically go to micro setting here and hit plus, and it should basically rearrange everything so that you're very close, although it didn't quite get it in this example. So it looks like we need to take out some date. So you can see just with a couple of clicks of date, you know, we're right back down there where we're crashing into Mars. See there. Okay, now the reason that we set the date 30 days prior to the eject date is because, remember, we are on the moon, and this is saying when we're going to eject to go to Mars when we are at Earth's periapsis. And we need to work out the timing so that we can leave the moon and arrive at Earth's periapsis, you know, down to an altitude of something, the lower the better, except of course you don't want to get into the atmosphere, but you know, 200 kilometers basically, or even like 180. We want to arrive at Earth's periapsis on the eject date. And it's going to take us 5 days. It's like 5.15 days, or 5.25. I think it's 5.15. It's going to take us about 5 days to go from the moon to the Earth. So that's why we set the date 30 days prior to the eject date, so that we can work out the timing there. Now we have the foundation of a plan for going from Earth to Mars, but of course we're on the moon, so now we need to work out how we're going to go from the moon to the Earth. We'll do that in stage 2, so go forward to stage 2 on the other MFD and go to view setup. And here, once again, we need to do the same thing. We need to go into the auto plan, turn it off, and we need to go to advanced and turn that on. And then that gives us access to our plan types. And we need, again, I'm going to have to guess here because I can't ever remember which is which. So cruise plan, we want the escape plan here, I believe. Let me see if that's right. Yeah, that's right. So auto plan off, advanced on, then plan type. You know, I can't understand why when you go backwards, sometimes it doesn't take you back to the previous variable. That's really irritating. So we want plan type initial, and then plan as escape. And then that lets us have the escape plan in stage 2. Otherwise, if you don't do that, it defaults to maneuver mode or something, I forget. Now we need to work out when we're going to leave the moon in order to arrive at Earth at this eject date. The moon's currently here, and it's pretty easy to understand that the moon needs to be here. It needs to be exactly between this V, this sort of V point. So that means that when we leave the moon from, you know, the moon's currently here, but it needs to be here. When we leave the moon, we're going to drop to Earth. Then we're going to kind of get that gravitational sling, and we're going to go out to Mars that way. You can understand easily enough that if we tried to do this now, if we tried to leave the moon right now, we would fall to the Earth, and we would be on the wrong side of the Earth. And that gravitational sling would actually take us basically exactly opposite, in the exact opposite direction. So we wouldn't go to Mars, we would go more in toward the sun. So this is where it gets a little tricky to work out the timing. But then that's why we left ourselves 30 days here. Of course, we can always adjust the date forward and backward. Now, I'm going to show a little trick that Dimitri showed me to figure this out. And for starters, we're going to go to View Setup. And we're going to change Scale to View to Target. And the reason that we want the target view is because this is showing us exactly where we need to be when we get to Earth. This line is showing us where we need to be, and we want to know in the other view, in this view, we want to know where the opposite side of that is at. So let's bring up the view scale to view to target. Now, you can eyeball it for one thing. If you can just sort of take your mouse and sort of say, you know, the opposite side is like over here. That's one way to do it. But a better way is to use some kind of line drawing utility.
Warning, center of gravity shift offline. Warning, center of
Ignore
gravity
that.
shift offline.
I just need to bring up this measurement tool. And what I'm going to do is I'm going to draw a line, and I'll put a link in the description down below where you can download this tool. I'm going to draw a line straight across like that, and you can see here that this exact opposite side is over here. If you try to eyeball it, you might not get it quite right, so it helps to have this line drawn. Now when I change the scale to view back to craft, I can see exactly where the opposite side of that line is at. And now you can kind of understand why we want that line, is because that line shows us exactly where the center point is between this and between here and here. And again, you can kind of eyeball it. You know, even if we didn't have that line, you can tell, like I said, if you just kind of follow it with your mouse cursor across, and you can say, well, it's going to be like right here by that minus sign. So you can, even without that line there, you can kind of just know that that's about the center point. But having the line helps, you know, helps us be more accurate. Now, what good does it do to have this line? Well, this line helps us calculate how far away we currently are from that center point in terms of how long it's going to take the moon to go from here to here. And we know that the moon takes about 28 days. It's actually 27.32, I believe, to orbit the Earth. So half that from here to here would be about 14 days. And if it were a 90-degree angle, which this is not, it's larger than 90 degrees, but if it were 90 degrees, then it would be about 7 days. So we can just tell by eyeballing this that this is probably 8 days away. But we don't have to guess on that either. If we actually measure the angle between here and here, we can determine how long it's going to take the moon to go from that position to that position. We can determine it with a very high degree of accuracy.
Warning. Center of gravity.
So I'm going to bring up another
offline.
tool. I'm going to bring up this triangular ruler, and it'll help me calculate. Just give me a second. I got to bring it down to the other monitor. For some reason, it always opens on the wrong screen. So I'm going to place this triangle exactly on the center point of the Earth. And now, as you can see, as I move the mouse around, it draws this line. And what I can do is I can use that to get the angle. So if I place the mouse cursor right over top of the moon's current position, I've got an angle of 219.41. Actually, that's not quite right. That's a little bit closer. 218.54, and you can see that where it says VARS stage 2 right above that, there's that little bubble. You have D equals 301, and then below that you have the angle, which is again 218.54. So let me write that down. 218.54. That's the moon's position. Now I want to know what this angle is. And this angle is 348.36. So let me write that down. And we know that the moon orbits this way, so we need to know what the difference is between this degree, between that angle and that angle. And we can do that with a simple calculator. It's just load plain old Windows calculator. And actually, while that's loading, I'm going to close out these lines because they make the frame lag really bad. There. Okay, so we've got the angle between here and that center position. And let me just think about it for a second. So we take 348.36 minus 218.54, and that's 129.82 degrees. That's the difference between that position and that position. Now, I'll put a little bit of information in the description down below about how to work out this calculation. It's really simple and you don't need a spreadsheet for it, but because I'm a little lazy, I'm going to use a spreadsheet. So there's a couple things I want to know. Today's MJD is 58238.0077. And the angle of the antipode, that's basically, that's this position, that's the antipode position. That angle was 348.36, and the angle of the moon's current position was 218.54. So there's a difference of 230.18. That's not right. That's actually, something is off with that calculation. The difference is 129.82. I must be doing these backwards. So anyway, once we have the angle, which is going to be this number, we can calculate when the moon is going to reach antipode, and that's going to be 2478595. Yeah, 58247. So we're saying that it's going to take the moon. Actually, something else I can put in here, which is going to be minus today's date. So it's going to take 9.851 days for the moon to go from here to here. So we can then take that number, 9.851, and we can add 5 days to it, because 5 days is how long it takes to go from the moon to the Earth, and we come up with a grand total of 14.851 days between now and the time that we need to do the ejection. So the eject date needs to be 58252.8595. And currently we have an eject date of 58267. So in order for the timing to work out, for us to go from the moon back to the Earth and then sling out, in order for that timing to work out, this current date isn't going to work. It's off by several days. So we simply need to adjust the date to the eject date that we come up with here, and that's 58252. So let me go to a medium setting. So we're going to go forward by several days, or we're going to go back by several days. And you'll notice as we do this, unfortunately, our angle here changes, but it doesn't change significantly. 58252, pretty close. 85, so basically right around here. Now it also changes our closest approach with Mars. So once we have the date set, then we have to go to the different variables, and we have to manually adjust the prograde outward in order to make the closest approach work. So let's go this way with it. Okay, that's the lowest point there. Okay, let's go backwards a little bit and then go back to prograde. Okay, back to outward. Back to prograde. And there we are, we're right back to Mars. Let me just refine this just a little bit more. And we're almost there. Okay, that's going to be good enough for now. We still have a little bit more adjusting to do. Okay, so once you have the eject date set, since this moved, we now have to basically recalculate everything again, because I'll show you. If you go back to scale to view target and we do this line draw again real quick.
Warning, center of gravity shift offline.
So now we're going to draw that line again, and you'll see that we're no longer, let me actually just go out beyond there. About like that. And we change scale to view. I thought I lost my line. That actually looks pretty good, but you can see that this line's no longer exactly where it was before. Before, this line was pointing to about right here. Now it's up here a little bit. So in order to have that precision that we would like, we just want to run through the measurements one more time, so that so that we have higher precision. And each time you run through the measurements, you have less and less discrepancy between, you know, what you set the first time versus what you set the second time. It's like granularity. You know, the first time we run through the measurements, our granularity is like, you know, medium. And then so we set everything up according to that. Then we'll do it again a second time and we have a finer level of granularity. And we may have to do it a third time, but usually twice is enough. So coming up to 30 minutes, so I'm going to go ahead and end this part of the video here. And when we come back, we're going to set up, we're going to do the second phase of the setup for measuring our angles and getting everything set up how we like. If you like this part of the video, hit the like button. Don't like it, hit the don't like button. Subscribe to the channel. Got a Facebook page. It's in the description down below. See you in the next part.